Right guys, let's start this tutorial on equations. Now equations, the more you practice, the better you get. You're often doing the same thing over and over again. So you've just got to practice, practice, practice. Now let's look at a couple of examples and then we'll write down some notes. Example number 1 looks horribly complicated. Now it's chosen because it is clearly a fraction equation. Now this first term here has a denominator of 1. The second term has a denominator of 6. And on the other side I've got a denominator of 2. And then I've got a denominator of 3. Now this is quite simple to algebraic fractions in that I need to think of a lowest common denominator. What is the lowest common denominator of 1, 2, 3, and 6? What's the lowest number that each of them go into? And the answer is 6. Now, the thing with equations is, what you do to the one side, you do to the other side. That's the golden rule. So, what you do to one side of the equation, you do to the other. As long as you follow this rule, you can't really go wrong in an equation. The only thing you have to be aware of is that you can never divide by a letter, because then you will lose a solution, and we'll see that later. So what am I talking about this LCD, and why am I saying what you do to one side, you do to the other side? Well, the idea is to get rid of denominators. I don't like denominators, and can I get rid of it? Now, if you multiply one term by a number, it means you need to multiply every term by that number, because what you do to one side, you do to the other side. Now the idea is to get rid of these denominators. So I'm going to rewrite this question, but giving myself lots of space. So I've got 4x minus 3 over 6 equals 3 over 2 x plus 3 minus 2x minus 1 over 3. Now lots of us fall apart at equations and make silly mistakes because we get lazy. Do yourself a favor and rewrite this question with gaps in an exam. Now this lowest common denominator is 6. Now let me show you why that is important. My golden rule says I can multiply each of these terms. Now notice I put a bracket around that because it's a complicated term. I'm multiplying each of these terms by 6. That's the golden rule of equations. As long as you do the same thing to both sides, you haven't broken any rules. So I multiplied each term by 6. Now these brackets are quite important, because if I don't put that bracket there, what am I multiplying by 6? Is it only the 4x I'm multiplying by 6? Is it the whole thing? So I always put complicated things in brackets. I'm not changing the meaning. I'm just helping myself out for the future. Now why this multiplying by 6 is going to be wonderful is, have a look. If you have a 6 in the denominator and a 6 in the numerator, they can cancel, which means that fraction is no longer a fraction. If I have 2, how many times does 2 go into 6? 3 times, and that fraction is cancelled. How many times does 3 go into 6? 2, which means that fraction is cancelled. How many times does 1 go into 6? Well, once, because that one denominator didn't really mean much. Now that's why we multiply by lowest common denominator, because if it's the lowest common denominator, it means that each of these denominators will divide into it, which means all of those fractions can become no longer fractions. So what am I left with? I'm left here with 6 times 2 minus, well, this 6 cancelled. So I'm simply left with 4x minus 3. Now look how important those brackets were. If I didn't have those brackets, then I'm only minusing the 4x. I'm minusing that whole, what was a fraction. So it's the whole of that numerator. So these brackets are very important. Here I've got 3 times a bracket. So I can do a little bit of simplifying here in my head. 3 times 3 is 9. And I've got x plus 3 minus 2 times 2, let's do that in our heads, is 4, and x minus 1. So simply by multiplying by my LCD, I've gotten down to a simple linear equation with no fractions. So all I can do is simplify 12 minus 4x and plus 3 is equal to 9x plus 27 minus 4x plus 4. Now, there's lots of ways to go about doing this. Ultimately, this is a linear equation. It's a linear equation because there's only x's in this equation. There's no x squareds. And as we'll write down in a second, our approach to linear equations are to get your x's to one side and your numbers to the other side. But this side looks like a mess, and this side looks like a mess. So I always simplify my sides first. So 12 plus 3 is 15. Minus 4x. And the other side, 9x minus 4x is 5x. 27 plus 4 is 31. Now it's a lot easier to work with. Now I need my x's on one side, my numbers on the other side. It really does not matter which side you put your x's on and which side you put your numbers on. You will always get the same answer. Lots of people prefer the x's to be on the left. If that's the case, that means 5x needs to be on the left and not on the right. So how do I get rid of positive 5x? I subtract 5x. Now why I do that is 5x take away 5x is gone. So I've gotten rid of it on my right hand side. The only thing is the golden rule of equation is what you do to one side, you do to the other side. So you may never write down minus 5x on this side unless you have the same thing on that side. So now I have 15 minus 9x, which means I successfully have x's only in one place. Now my x's are fine. I want my numbers on the left, which means I have positive 15. So I have to minus 15 as long as I do it to both sides, which means I'm left with minus 9x, and 31 take away 15 is 16. Then I want x by itself. I don't want minus 9x. So how's that minus 9 connected to x? Multiplying. How do you undo multiplying? I divide by negative 9 on both sides, which means my negative 9 divided by negative 9 is 1. So I'm left with x, which is 16 divided by negative 9. Now, you can use your calculator to see if that's simplifiable, but I know that nothing goes into 9 and into 16. So positive divided by negative is negative. 16 over 9 is the simplest I can get. Now, if I had time at the end of the exam, I would take this and go put it back into my original question and see whether it works. I would do that at the end of the exam just to check myself. Let's have a look at another example. This is also an example of fractions, except this time these denominators seem complicated. Now, this is very similar to algebraic fractions again. This denominator is clearly not in its simplest factorized form. And maybe if I factorized it, I could build my lowest possible denominator. So just as in with algebraic fractions, I'm going to factorize this. If you've practiced your factorizing, you'll realize this one's quite easy. It's minus 4 plus 1. And this is 3. This denominator can't be factorized. And can this denominator be factorized? Absolutely. There's a common factor of 2 and an x plus 1. Now, why we factorized is then I can build my lowest common denominator. I clearly need an x plus 1. I need an x minus 4, which means that'll be in, that'll be in. This is fine, but I need a 2. Now, this means I can multiply each one of these terms by my lowest common denominator. Remember in equations, what you do to one term, you do to every term. So I can multiply this by 2x plus 1 x minus 4, as long as I multiply this by 2x plus 1 x minus 4, and I multiply this by 2x plus 1 x minus 4. Now in an exam, I would have written this again with much better spacing so that this isn't so crowded and the equal sign in the middle of nowhere. It's very bad mathematics to write it like I have. So in an exam, take a line to space it out. Now why have we done this? We've done this, oh, I should never put an equal sign there ever. Only one equal sign on a line. So please never put an equal sign. I can put therefore or nothing. Now why have I done this? I've done this because as long as I multiply each side by the same thing, I'm fine in equations. I'm allowed to do that. And why this works nicely is now I've got an x plus 1, an x minus 4, and x minus 4. So that entire fraction simplifies to x plus 2, and I've gotten rid of my fraction. In the next one, my x minus 4 cancels, so I've got 3 times 2 is 6, and I've got x plus 1. And last term, I've got x plus 1 cancels, so, oh, and my 2 cancels, so I've got 1 minus 1 and x minus 4. And now I'm back to a simple linear equation, which means I multiply it and collect up like terms. So I've got 2x plus 4 equals 6x plus 6 minus x plus 4. Now I always simplify each of my sides before I continue. So this side would be 6x take away x is 5x plus 6 plus 4 is plus 10. Add x's to one side. I'm going to take them to the left, so I'm going to minus 5x on both sides because 5x minus 5x would cancel, which means I'm left with minus 3x plus 4. And then I'm going to minus 4 on both sides because 4 minus 4 disappears. So I get negative 3x is 6. And finally, it's minus 3 times x. So I'm going to divide by negative 3 to get rid of it. So I've got x is equal to negative 2. Again, in an exam, I would go and substitute my x is equal to minus 2 back into this original equation if I had time at an annual exam, just to check if I've got it right. So let's just quickly write down an approach to linear equations. First of all, they could be complicated. So if they're complicated and have fractions, I would factorize all denominators. Then what I do, if you noticed, I build a lowest common denominator. Then what I do is I multiply each side by my lowest common denominator, in the hope that that will cancel. Every single one of those denominators will be cancelled, and I no longer have fractions in my equation. Then it's quite simple. Then I'm back to a simple linear equation. I distribute and collect up like terms, and collect like terms. And then comes to the most important things to remember with approach to linear equations. For linear equations, you get your x's to one side and your numbers to the other, always. It's very different in other equations, so it's very important to remember x's to one side and numbers to the other side. And then you can isolate x. That's my general approach to linear equations. Now, I'm going to start a new video to look at this example, which is the difference between an expression and simplifying an expression and equations, because this is where most grade 12 math students fall down. So start the next video on equations and inequalities, because this is quite important.